All right, today we're going to dive into building a real-world AI model to catch credit card fraud. But listen, this isn't just about getting a high score. It's about figuring out what it really takes to build a system a business can actually trust, especially when every single prediction has a dollar amount attached to it.
I want you to look at this number, 0.17%. That's the tiny, tiny fraction of all credit card transactions that are actually fraudulent. Seems pretty insignificant, right? Almost nothing.
Well, that tiny fraction, it's a huge problem. That 0.17% adds up to billions with a B, billions of dollars in losses for banks and financial companies every single year. And that is the problem our AI needs to solve.
This chart right here really puts it all into perspective. The vast, vast majority of what's happening are normal, everyday transactions, that huge blue area. And then you see that tiny little orange sliver? That's the fraud. We are literally looking for a needle in a haystack.
So here's our game plan. We're going to start with this whole needle in a haystack thing. Then we'll see why a 99% accuracy score is totally useless here. After that, we'll talk about making our model's predictions trustworthy, the real cost of its mistakes, and finally, we'll look at two different goals to find the right real-world answer.
So let's kick things off with the heart of the problem, this challenge of what we call imbalanced data. The difficulty isn't just getting an AI to work. It's getting it to find that incredibly rare fraud signal in this overwhelming sea of perfectly normal activity.
And because of this massive imbalance, the tools we normally rely on to measure performance, they just break. And this is a really crucial point. The most common way we judge AI models is completely, totally wrong for this kind of problem.
Okay, check this out, because this is a bit of a mind bender. Imagine a model that does absolutely nothing. It just guesses not fraud for every single transaction. Because fraud is so rare, that lazy do-nothing model would be 99.83% accurate. You'd think it gets an A+, right? Nope, it's 100% useless, because it would never catch a single fraudulent transaction.
And that's exactly why the source analysis is so blunt about it. It just says accuracy is meaningless here. It's what we call a vanity metric. It makes you feel good, but it tells you absolutely nothing about whether you're actually solving the real business problem.
So, if we can't use accuracy, what do we use? Well, the pros use a metric called AUPRC. Now, I know, it sounds super technical, but the idea is actually pretty simple. AUPRC focuses only on how well the model does on that tiny group we care about, the fraudsters. It's the perfect tool for measuring that real-world trade-off between catching the bad guys and accidentally flagging innocent customers.
Okay, so now we have the right yardstick, the right way to measure our model. But there's another absolutely critical step. See, it's not enough for a model to just flag something. We have to be able to trust its level of confidence. And that brings us to something called calibration.
You know, think of it like a weather forecast. If your weather app says there's an 80% chance of rain, you expect it to actually rain about 8 out of 10 times, right? Well, calibration is just the process of tuning our AI model so that when it says there's an 80% chance of fraud, it's telling the truth. It makes the model's predictions something you can actually rely on.
Before we do this, a model is often, well, it's overconfident and unreliable. It might spit out a 90% fraud score for a transaction, but in reality, it could be wrong way more often than it's right. You just can't base expensive business decisions on that kind of guesswork.
But after calibration, it's a total game changer. The model's scores become dependable probabilities. An 80% prediction now truly means an 80% chance of fraud. Now that is something a business can act on with real confidence.
So we have a trustworthy model. Awesome. But to actually use it, we need that final piece of the puzzle. We have to understand the real-world financial consequences when our model inevitably gets something wrong.
And this slide shows you just how high the stakes are. On one hand, you have a false positive. That's when we flag a good transaction by mistake. It costs about $5 to investigate, and it really annoys a good customer. But on the other hand, you have a false negative. That's when we miss real fraud, and that is a catastrophe, costing an average of $200. Missing fraud is 40 times more expensive than a false alarm. That's huge.
Okay, this is it. Let's put all the pieces together. We have a powerful, calibrated model, and we understand the costs. Now, the analytics team has to make a strategic choice, and it's driven by two very different business goals.
Strategy number 1 is all about protecting the customer experience. The goal here is to be extremely precise. Basically, we want to be at least 90% sure that when we flag a transaction, it's actually fraud.
This is all about not bothering good customers with false alarms.
And here are the results. The model caught 54 fraud cases, which is great, but look at that false positives number, just 6. Only 6 legitimate transactions were flagged by mistake. That is incredibly precise and a huge win for keeping customers happy.
But what if the top priority isn't happy customers, but pure financials? Well, strategy number 2 focuses on protecting the bottom line. The goal here is simple. Just find the setting on the model that results in the lowest possible total cost from all errors combined.
Now look at this trade-off. To minimize cost, the model has to get a lot more aggressive. It catches more fraud, 59 cases instead of 54, which is good, but it does that by flagging 44 good customers by mistake. So the financial loss is smaller, but the impact on customers is way bigger.
So we have 2 different strategies, 2 really different outcomes. And this brings us to the final real-world answer, where we're about to see that context is absolutely everything. This final table just lays it all out. If you look at the customer-first strategies, they have very few false alarms, but they cost more money overall. Then look at the cost-first strategies. The costs drop, and one model even gets down to just under $3,200, but it comes at the price of 78 false alarms. So this leads us to the big question of this entire exercise. After looking at all this data, all these trade-offs, which model, which strategy is truly the best one? And the answer is, there isn't one. It completely depends on what the business wants to achieve. And this whole journey reveals a really powerful truth about using AI. For it to be truly useful, what's more important? Chasing a perfect score? Or making a smart, cost-aware decision that solves an actual real-world problem? As we've seen today, the smart decision is always the right answer.